The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
I think we're going to go ahead and get started, everybody. Hi, my name is Michael DeHaan. I'm the CTO of Ansible Works, and Ansible is a project I started about a year and a half ago, so we're going to talk a little bit about IT automation. So a lot of people kind of wonder, well, is this talk for me? Why am I here? This is a talk that would be good for you if you're managing operating systems, if you're deploying applications, so whether you're a systems administrator or a developer, you know, following DevOps things, not following DevOps things. Maybe you've got more than one machine in a home lab, right? So there's a lot of different cases where Ansible can be a good fit for you and your infrastructure. And also, you know, we're very good about managing network devices, so we're doing a lot of things with different network vendors. So if you have, you know, an interest in automating network things, this is also a very interesting tool that you might like. So the equation behind Ansible is essentially flexibility plus simplicity is power, right? So if we think back to a lot of the IT automation tools we might have dealt with, some of them are very, very flexible, but they're very complicated. And then some are very simple and pointy, clicky, and so on, but they're not really good for managing any more than like one single machine at a single time. So the experiment when I started Ansible, and I kind of started it on my couch, was can I somehow bridge these two worlds? Can I find a way to make things simpler and easier? So before I dive in a little bit, is anybody using Ansible right now? Oh, awesome, great. So is anybody maybe using like Puppet or Chef or Fabric or Capistrano? Okay, all right. So anybody else doing kind of like in-house scripting and automate their own systems? Excellent. All right. So you're all my kind of people, and I kind of know what we're talking about here. So to give you a little bit more information about myself, I'm an NC State grad. I live in Raleigh, so not too far to get here. I originally started work at IBM and Adaptec, did a lot of storage management software, automation around how do I set up drives and servers and things like that, and eventually found my way at Red Hat. So at Red Hat, we noticed that there was a lack of good reusable automation around how I deploy servers, right? So everybody was writing their own things to set up Pixie and Kickstart and so on. So I created a project called Cobbler, which some of you may have heard of, and another project that was also kind of automation driven called Funk. And Funk was all about how do I talk to a lot of servers at a time right now and kind of construct an API for managing my server fleet. Funk was kind of built to fill in some gaps around that kind of existed between Cobbler and a lot of people, other DevOps-y kind of tools that people were using at the time, like Puppet and Chef. I actually ended up working for Puppet Labs for a while, and I came out of that and I said, well, I'm encountering all these places where I really want some capabilities that I didn't have in existing tools, right? So one of those was how do I control real-world IT architecture? So you have web servers and database servers, and you have, you know, load balancers and firewalls, and there's really this topology of systems that I want to manage. And I want to model those IT processes. I don't want to necessarily say, this is the configuration that just goes on this one system. I really have a workflow that I want to walk through. And there were a lot of commercial orchestration tools at this time where I could drag in blocks and move things together, but they weren't the tools that I wanted to use, and they were very expensive. And I kind of want to say, how could I do this better? How could I also solve configuration management better? And also build a tool that could deploy apps. So we saw a lot of people that were taking a configuration management tool and adding a application deployment tool on top, and then gluing that together, and then gluing it together with their provisioning system, and gluing this over here, and then writing a whole bunch of automation on top. And this was kind of getting repeated at every single data center site across America, right? So how can we build less tools and simpler tools that do a little bit more and look at things a little bit differently? So that's kind of what I'm very interested in, is sort of the automation case, because if we're going to achieve Skynet and ruin humanity forever, this is the next step, right? That we have to get there first. And if we do it right, maybe the robots will like us and be friendly. So as I kind of mentioned, Ansible started in February of 2012. Started for a lot of different reasons. One of them, like I said, is I had a lot of experience with configuration management tools and kept wanting to see them made simpler. There's a movement called infrastructure as code that a lot of people have heard of, and that's fine, but I'm a software developer, right? So I think if you're in software enough, you actually learn to dislike code, right? Because it's buggy and hard to write, and I really want to slam something out quickly that's also maintainable and audible and readable, that when I develop it, I can go in there and everybody on my team can understand what it says, and we'll talk a little bit about some of the simplicity and show some examples. But Ansible is trying to move away from infrastructure as code and get into what I'd like to call infrastructure as data, where it's more policy-driven, more human readable, something that's accessible for all levels of the team, whether you're a developer or a systems administrator, whether you've got 500 other projects and you want to move quickly between this project and this other project and don't want to necessarily, say, be a jockey to one particular automation tool all day. You just kind of want to implement what you want in Ansible and get going. So we've been kind of blessed with a really active open source community, and we're pretty much one of the fastest growing open source automation projects today. 1,650 followers on GitHub in a little over a year and a half. 530 forks, very, very healthy mailing list, very active IRC channel. So there's lots of resources if you're starting to get going to talk to people. And we have this last release, for instance, added 30 new modules, and we'll talk a little bit about what Ansible modules are, but growing extremely, extremely fast, and it's been very fun. So some of our users today, I'm not going to talk too much about this slide, but there's some pretty cool use cases. So AppDynamics is one of the coolest Ansible deployments I know of. So they're deploying every 15 minutes. So they check in their changes to their configuration management policy and their code. It's wired into Jenkins, and then every 15 minutes, Ansible just washes over their entire infrastructure and rolling update and gets their latest code out, right? So very cool deployment case. Gawker's doing a very similar thing with, so if you're reading Jalopnik or something, that's all Ansible powered. We see a lot of people that are very interested in Ansible kind of in the big data case. And that's kind of a performance thing, right? So I'll get into some of the architectural features as to why Ansible is really, really interesting for high performance clusters in a little bit. Also, on that last previous slide, edX is an interesting one. They've recently open sourced all their configuration management for their education solution, so you can go on GitHub and see their playbooks in Ansible, which is a really cool thing for people to be doing. edX. So that's the Harvard, MIT, Stanford OpenCourseware. So the big thing that's different about Ansible that really hasn't been done before in configuration management, it's kind of been done a little bit in an app deployment, but there's never been a good bridge between those two worlds, is to build an agentless solution. And by agentless, what I mean is there's no management agents that are required on the remote machines. So normally, if I'm dealing with an enterprise management solution, I'd have to install these root level daemons on all my machines, right? And these daemons would consume resources, but I'd also have to worry about how I got them there in the first place, how I update them. In rare cases, they can be a security hassle if I have to get a security update out. Can I actually update the management software using the management software? I have to open additional ports in my firewall. And kind of what I meant a little bit about the HPC case and the big data Hadoop case and things like that, they'll cut into your performance in your RAM, right? So especially if you're running a virtualized infrastructure, if a daemon consumes 40 megs of RAM and you're running 10 instances on a box, you've just consumed half a gig. If that daemon's swelling to 400 megabytes, you have some serious, serious issues. So we're stepping back and basically saying, when I'm not configuration managementizing is that a word? I don't think so. When I'm not managing the machine, there's nothing out there to be doing anything. So it's just completely off. The other cool feature about Ansible is what I'd like to call true orchestration, and maybe that's not a right word. I occasionally try to call this multi-tier, multi-step orchestration. But the idea that I'm modeling a data center architecture, I'm not just saying blast this out to all these systems. So the idea that in an update, suppose I have a web tier and a database tier and an app tier and some content servers, and I have a rolling update process. I worked at a hosted web application company once, and we had a very modest number of servers. I think it was about 150. And they would actually lock themselves in a room for up to 3 or 4 or 5 hours, and it was turn your keys over here, now turn your keys over here, make sure you do the right thing at the right time. And what happened was people would typically kind of get this process slightly off in one particular thing every time, where I forgot to update the content server, I forgot the symlink, I forgot step 32, and it would result in problems. So if I want to roll out my application across the stack, can I model it in Ansible's language, which I'll show a little bit of very soon, and make this repeatable and really, really easy? Data sharing between nodes is very important too. So suppose I have a firewall and it needs to let all the database, all the web servers connect to all the databases, right? So I can actually say, use all the variables from these other machines, gather their IP addresses, right? And use those IP addresses to construct a template for the firewall. These are things that are doable in a lot of existing tooling, but in Ansible it's really, really easy. It doesn't require a server, it doesn't require a database, and that's kind of an elegant thing. Load balancing and rolling updates, right? So suppose I have 500 servers, right? And I want to maintain capacity and uptime, and I need to update my software, but not take the site down. So what I might want to do is I might want to carve out 50 servers at a time, completely update those 50. But before I do that, I need to take them out of the load balancer, right? I want to take them out of monitoring so my pager doesn't go off. Well, nobody uses pagers anymore. It doesn't trigger crazy alerts to your cell phone, right? Update them completely, and when they're successful, put them back into the pool and move on to the next 50 and keep going down the stack. So rolling updates are something that Ansible is really, really good for, and also dealing with your monitoring and your load balancing along the way, which makes it a really good continuous deployment system, right? So this is basically the thing. So I have an arbitrary set of code in my repository. It doesn't just update this one set of systems or this set of systems. It talks to my entire IT infrastructure in a very well-defined order, not just saying, here's the configuration for this node, but here's this whole IT architecture and the process to update it. So I can hook it up to something like Jenkins or Bamboo or what have you for continuous integration, and have it, maybe it deploys continuously to my stage environment, and when some tests pass, it deploys to production. Maybe I'm deploying to my QA environment, but it's easy to graph these two systems together in interesting ways. And the other property that this gets you, kind of based on its architecture, because Ansible is pushing out to remote systems instead of waiting for them to check in, is that it has a very rapid execution cycle. So rather than saying my web servers check in and they wait 30 minutes, and then my database servers check in and they wait 30 minutes, and this other tier comes in and it waits 30 minutes, and I've got like locks in place to say this must happen, and once this is true, this has happened. I can actually push out my app stack as fast as I can possibly go. Because once this step is done, it can go on to the next step. It doesn't have to wait for the systems to kind of phone home and be ready. So this is just a very simple diagram of what this looks like here. So again, if we're a multi-tier set of systems, it might say carve out 10 of my app servers at a time. Before I talk to them, pull them out of the load balancer, signal an outage window in the monitoring system, update them completely, put them back in, put monitoring back in, and then keep moving down the line. So this diagram shows a little bit about the Ansible architecture. It actually looks more architect-y than it really is. By default, it's a very decentralized system. So if you think about Git or Mercurial as a source control system, Ansible doesn't require a server, and it doesn't require any agents. So typically, while you might decide to run it from a central management machine, you could also easily just take a laptop right into a data center and start managing machines, because it's it's operating over SSH, right? So when we say it's operating over SSH, a lot of people think it's logging in and it's running chown and chmod, and that doesn't work, right? So everybody said, it's impossible to write a SSH-based management system, right? Because that's the kind of the way they were thinking. But what Ansible does is it transfers very simple modules to the remote machine, and it runs them. So these modules are little pieces of code. All the core modules in Ansible are written in Python, but you can actually write them in any language. So if I wanted to write them in Ruby or Perl or Bash, I can go in there and still write a module. And all it needs to do is be a very simple program that can read some input and return JSON. And Ansible can parse it and run it. So what it'll do is it'll actually transfer this module file to all the remote hosts and run it, execute it. And when it's done, it'll remove it kind of all in one step. So what we're doing is we're actually able to transfer smart programs and descriptions of resource state to the remote machine. And if you're familiar with some of the other DevOps style automation tools, you hear a lot of talk about idempotent resource models and so on, describing what state you want a system to be in rather than the steps to take it from point A to point B. Ansible is exactly like that with all of its modules. So I can say this package should be installed or this package should be at this version rather than issuing a command that says do specifically this. And you'll be able to tell what resources have changed on the remote system. But you'll also be able to run it in a dry run mode and say, when I run this playbook, which is what we call our descriptions of orchestration, right? You can say that what resources would have changed if I would have run this for real, and then you can decide whether or not you want to run it. There's kind of a growing theory among some of our users that if you continually manage your systems, all the time, and you're like, I actually want to think about why did this change when I wasn't expecting it, and see, is that a sign of an intrusion or so on? So that can be a useful thing to do. Ansible is also very pluggable. So there are modules for callbacks. So I could say log this to an extra database or a message bus, or I could say perhaps I want to write a new transport for a different way that Ansible might connect to remote systems. For instance, we have one that comes in Ansible. It's called Fireball, right? So SSH is ordinarily really decently fast if you're using control persist, control master, right? But if you want to go even faster, we have this this Fireball transport. And what it will do is it'll transfer a very small helper program to the remote node. And if you remember, you'll say I said we were agentless, right? Well, what it does is it fires up this little temporary agent running the 0MQ message bus. And it has a time to live, basically. And then after, say, 30 minutes, or maybe you chose an hour, this daemon will self-destruct and it'll go away and leave no traces on your system. But what it did while it was running is it provided you an extremely fast transport out to all your nodes. But it used your SSH credentials to establish the secure link. So with Ansible, you don't have any of that public key infrastructure to maintain, right? Which is a really nice feature. So my OS credentials are in play. So if, for instance, if I wanted to set up Kerberized SSH against all of these machines and manage all that centrally, if I was using LDAP for authentication, Ansible works with your native OS authentication. Most people end up using SSH keys, but you can pretty much pick things as you want. If you've got a really small lab and maybe it's not really wired to the outside internet and you're cool with that, you could actually log in with passwords if you felt like it. Then that also means that you don't have to worry about NTP synchronization and needing DNS. And there's some really cool things that architecture allows. One of our really coolest use cases is actually not about computers at all. Well, everything's a computer, right? But there's this guy that has 200 vending machines in Sweden, and they're different Coke machines with cellular modems in them, right? And he's using Ansible to go talk out to his vending machine fleet and upgrade them. And there's like a kiosk, 20 or 30 of them, I think, in the Melbourne Zoo, right? That tell you all about the different animals and so on. And these are kind of places where it's very lightweight, kind of embedded computing, and doesn't need to have the same demands as traditional data center architecture. So it fits in some interesting places. Obviously kind of designed for the data center, but some nice other features. Playbooks are your automation language, which I'll show later. And host inventory can be written in text files. It can be pulled from a database. It can be pulled from the cloud, like EC2 and so on. OpenStack, things like that. So keeping things simple. So this is kind of a philosophical thing. When I set out to build Ansible's language, I really wanted to make something that was readable for both machines and humans. And this is an interesting challenge. So I'm using YAML as a data format, and YAML is YAML ain't markup language, which is a terrible, recursive acronym. But it's a very, and I'll show some a little bit, very white space-y data representation. So if you're familiar with JSON from JavaScript, object notation, right? It's kind of like a lighter weight JSON that you don't quite have so much quoting. So it's easier for humans to enter and read, but also parsable by machines. We had a manager that said once that I can basically write down a list of orders and hand them to someone and say, I need these things done on these machines. He can write an Ansible playbook, hand it to somebody, come back and say, yes, this is the automation that I wanted, right? And he, not even knowing the tool, you can kind of understand what it does. So Ansible basically is there to provide you very simple, very prototypical ways of doing things. So Python as a programming language, though they were written in Python, that you don't write things in Python here, kind of has that similar philosophy to me. So I can write a very simple program, come back to it later, be able to read it, but also my first attempt at writing it was probably the way that it needed to be in the long term to be maintainable. So there's this rapid prototyping, also usable in production balance that feels really good. Another thing we've been doing with Ansible that I'm really, really happy with is we've kind of have this batteries included philosophy. So rather than having a lot of people write their own content and then share it, and you have to go find what's good or what's bad and so on, we basically ask everybody to come together and work on the same project together and contribute to the same modules. So what we've done is we have a very large pool of community modules. We added over 30 modules this release. We added almost 30 the last release. And they allow you to do all sorts of IT things that you might want. So it's basically a huge craftsman toolbox of things that you want to do. And we're very welcoming of new ideas and features. So the kind of criteria is if a module is going to be used by maybe 5% of the users, or it's a very major service that everybody knows about, we'll definitely take it in. We're not going to take in this one Linux distribution that's used by like 4 people. That's something that we'll link to on the website and tell people to use. But if it's something popular and it's well written, we'll include it. So we have a lot of modules here for managing. I've only listed a small amount. There's actually over 100 in core now, but a lot for EC2. So EC2 load balancers. S3 modules, EC2 node creation, so you can actually provision new systems with Ansible as opposed to just managing existing ones. We have a great suite of new monitoring modules in. We had a Nagios one for a long time, but people have added modules for even hosted web services like Pingdom and PagerDuty, Airbrake, so on. There's been a lot of notification modules recently. So if I'm writing a playbook and I want to say notify my chat server to tell everybody that it's about to go down on my development team, I can do that. Modules for pip and gem and homebrew and all, interesting ways to get software beyond yum and apt and so on. Of course, we have those too. So there's a lot of really, really good stuff there. Big IP and NetScaler for managing things. We're looking to have some other networking vendor modules in very, very soon now. But basically, anything's kind of fair game. So if you go to ansible.cc/docs, you can click on the modules page and see all about what's in there. So I'm going to show you a few examples of syntax, and looking at my watch a little bit, I may have a little bit of extra time to go in and show you some of the stuff in the Git repos. So this is an Ansible inventory file that basically you can pull from the cloud to get your inventory. So get your dynamic hosts from EC2 or OpenStack and a few other data sources. There's one written for Cobbler, for instance, if you want to keep all your inventory in Cobbler. but you basically define groups of systems and you put hosts into those groups. So a group could be a role that the system is going to fulfill, like a web server or a database server. But it could also be a geography, like Boston or so on. I can also put groups in groups, and I can also assign variables at this point. This is talking a little bit about what I said about dynamic inventory. Another one of our things we support is Spacewalk right now. Should also support Red Hat Satellite Server in the near future. OpenStack Nova, I mentioned. And you can also write your own. So if you want to keep your inventory in LDAP, or you decided that maybe I wanted a little bit different data format, or maybe you were feeling a little bit enthusiastic and wanted to keep it in a spreadsheet or something, you can actually do those kind of things, right? And you can also use more than one data source at the same time. So for like a hybrid cloud solution, you might pull EC2 dynamic inventory and then also add in the machines in your data center. So you could kind of define cloud bursting configurations and things like that. So Ansible has two major commands. There's Ansible and there's Ansible Playbook. So Ansible is the way that you execute modules just in kind of like one shot. So this one module runs against all my machines, right? So if I want to say every one of my machines that's in the stage host file, right? Or maybe that's a dynamic inventory script, just ping them and see if they're up. I can do it like that. Very, very simple. I'll show you some examples later of that output. But I can also match systems by expressions, or I can actually say host in this group and not in this other group, and things like that. I can say run against all my web servers. Here I'm showing all my web servers that happen to be in Charlotte in production, and shut them down in 2 minutes. So it's a really good way to say, do this right now, boom, with user bin Ansible. The main interesting thing, though, is Ansible Playbook. And this is where we spend most of our development time in Ansible and most of why people are interested in it. And Ansible Playbook is our automation language. So here you basically say, I'm going to define my configuration in the YAML file and run it. So what does one of those files look like? So this is probably a little hard for everyone to read. But if you go to ansible.cc/docs, you can see lots of information about how to construct these. And there's also an Ansible examples repo on GitHub. And that'll help you understand as well. But what you do is you specify what hosts you're going to talk to. In this case, we're talking to all of our hosts. And we're using, right here now, we're showing a new feature in 1.2 called roles. And it's just an easy way to group and categorize content. So we're saying all hosts get the common policy, right? We're saying the database servers, which I'm going to log into using my root account. Here we're assuming, say, SSH keys or SSH agent was used. We're going to get the database server policy. Here the web servers get, whatever. And you can see it's just a very simple data format, not a lot of syntax. And what one of these roles files might look like on the inside, I can show more later. You can look at the doc site to get a little bit more. Is we're selecting a module to use. Here we're using the Yum module for package management, right? And we're passing in some orders. Here we're specifying a list. So here's this with items, right? So we're installing 4 modules here, or excuse me, 4 packages. But Ansible's smart. So it says that it sees that you're installing a package list, and it'll do all that in one Yum transaction, and it'll be nice and fast. Here we're setting SE Linux Boolean. There's a template module in Ansible as well. So if I have a local file that's a template, I can apply it with all the variables that were defined in my inventory and in my playbook. I can also dispatch tasks and then save those in variables. So I could say, if I wanted to say what's the uptime of all my hosts and then put it in in some sort of report file, I can do that. The interesting thing about Ansible, though, is the order is the way that you put it in. So it's very easy to not only do a configuration management, but also focus on app deployment. So if I want to transfer a tarball, decide that if this file is missing or the wrong version, I want to extract it, install it here, perform these other steps. I could do all those sorts of things in a very deployment-oriented, straight list of things. So the idea here is we're just exposing the system as what you think of it and trying to keep it all really simple. There's also some modules in here for doing things with MySQL and Postgres users and things like that. So here you can kind of see that this is sort of the template language in Ansible, so how we evaluate, we can put variables in and so on. So when you run that playbook, you're going to see something a little bit like this. So you're just going to see a list of all the tasks, and then it's going to report whether things are changed. If I were to run that with the -v, it's going to show more details as the result of all those commands. And we're also working on a very interesting server solution that's going to be called Ansible Works Suite. And what you're going to be able to do is get all the history of that over time, and we're going to be making some announcements about that pretty soon. And it'll provide you a nice web-based way to launch things and so on. So what's really nice at the end is you get this play recap. So what that'll tell you is the number of steps that ran under each host, how many failures each host had, and so on. So you can see the errors. Ansible is also a fail-fast system. So if you had an error in a particular host, like if you're updating your web servers in rolling update, you're updating 50 at a time, and the first block completely failed, right? It's going to stop the entire update process, leave that 450 online. It's not going to walk through the process and say, update all 450 servers to be broken. And it's really good about being able to inject unit tests into the middle of your playbooks as well, because since it's really just this free-form list of things, I can put in a step here that says, test, make sure it works, right? And if that were to fail, it would stop my rolling update, and I maintain my uptime. So what's next for Ansible, right? So I mentioned the UI and the REST layer that we're working on, but I think the general theme is kind of more modules, right? So the language is going to continue to improve and add things, but I take a really hard stance on backwards compatibility, as I don't want people to have to update their content as new copies of Ansible come out. So we'll probably add new language features over time, but we definitely weigh that to make sure that everything we add is going to be good for everyone. And then there's just this barrage of, here's all these cool services, right? So let me have this great toolbox of batteries included things. And it's very, very nice to see that explode, and in very interesting ways, seeing people start to share playbooks and so on. We do releases every 2 months, which seems to be a pretty good frequent interval, but there's a lot of people that'll actually run straight out of GitHub, right? So we have a pretty good ability to test everything and keep it working and move forward. So some people are like, I'd like the new features, I don't want to wait for a release. And because there isn't a server and because there aren't any agents, you can stay up to date with the very latest GitHub and actually run it in production. And as scary as that is, there's lots of people doing that, and you can do that. So 1.2 is actually going to release Monday. So if you want to start playing around with some of the new features like roles, which I mentioned, and some of the new templating and so on, I definitely recommend you start from GitHub, and you can do a checkout, and there's a script inside the checkout in the hacking directory called env setup. And if you source that script, it'll set up your environment to run straight out of source, and you never have to install it at all. So that's pretty cool. We're also obviously in all the distributions if you want to do a yum install and things like that. You'll get version 1.1 though, so 1.2 is so much better. A few links to kind of, before I jump into some questions, and if I have some extra time left or people are interested afterwards, I'll fire up my laptop and kind of point around some resources and some playbooks. Our company is AnsibleWorks.com, so we're doing typically kind of the open source consulting and support and services kind of thing. So if you guys want to get some help getting started with Ansible, we're here to do that and be very interested in talking to you. Also building, like I said, some very nice solutions on top that we'll be announcing soon. Community website is at ansible.cc, where you can see all about the GitHub repositories and cool things that are going on. Very active channel on Freenode is #Ansible if you want to join us in IRC. There's Ansible project on Google Groups. Mailing list, good place to get support and questions. I am Laser Llama on Twitter. Do not ask me why. But I am, and Ansible Works on Twitter, and then my email is michael@AnsibleWorks. So obviously I was talking a little fast. I didn't get too much chance to dive into a lot of the playbook content, so I'd like to show some of that, but does anybody have any questions before we get going? Yes?
How hard is it to get Ansible to work on a proprietary device that only supports CLI, but doesn't support like SSH? I won't say what it is, but it's just basically just you log in
Yeah. This is Cisco router. All right, absolutely. Yeah, there's a lot of devices like that. So what a lot of people are doing for those kind of situations is they're using a local module, and Ansible has this thing called local action, right? So what it says is I'm going to run the module on this server and then talk to it something remotely. So in many cases where something has an API, the module will run locally, whether that's SSH or even just locally, or on behalf of some other host, and it'll talk to it that way. So in the case of your device that has that CLI and so on, you might end up having to write a module that has some expect-based logic, right, and some funness.
It also does, I can do XML-based, JSON stuff.
Oh, great, yeah. Definitely some other networking hardware gets in that model. Yeah, so the question, I'm sorry, I'm not repeating all the questions for the microphone. So we were talking about different devices that don't necessarily do SSH and how do you talk to them and RESTful things. So that would also be a case of your module probably speaking REST to the remote thing. And as long as it returns JSON, it's easy to plug it into Ansible. Yes?
How does it compare to Salt?
The question was, how does it compare to SaltStack? So SaltStack was a project that a guy started based on Funk, which is a project that I wrote. It uses a 0MQ-based message bus, but it does all the same crypto as Puppet and Chef. So to me, SaltStack feels like a Puppet and Chef port. And while it's new, it has I don't want to say too many things about different competing projects, but I feel it's kind of immature. It has a very, very high open bug count. So there are some good things about it. I like the way that it claims that it has this massive scale-y kind of thing. But on the other hand, I'm a little disappointed that it looks like a Puppet port. With Ansible, we're definitely going for a very agentless approach. So not having the root level daemons where you don't have to worry about the security issues. And also having a really, really good multi-tier orchestration solution, right? So what that means is I'm able to talk to my web servers and my data servers, and then going back to my other tier, right? And being able to share all that information back and forth and deploy my whole systems architecture. So a lot of systems in this space tend to look at configuration management. Like they say, well, yeah, I need to push out these templates and these files and so on. But when they come to actually modeling a process of pushing out the software, people will typically have to strap Capistrano or Fabric on top, right? In Ansible, what I wanted to do was actually blend those together to where I can have a very good order-based system, not have to wire the dependencies together. So I can actually deploy that in a straight line and say, this is the OS. Now here's the process for the apps. And maybe it's checking out the tarball. Maybe it's doing the get thing. And have a really fine-grained, very simple way to blast all that out. So hope that sort of answers things. So obviously there's different topologies of scale. So Ansible pull is a way that you could invert the architecture if you want to go in pull-based mode. But the best data I have right now is a tweet this morning from Rackspace. They're using us on 3,900 machines. Yes?
How do you know, so you don't check the state of the device, so I just upgraded 75 MySQL databases and they all failed. And oops, I just upgraded all the other things after I had not successfully completed the first thing. How do you deal with that?
I'm not sure I completely understand. The question was about updating servers and not checking.
Yeah, you say you do asynchronous, you basically go without actually checking the status of it.
That's actually, okay, so the question was were we asynchronous and didn't check the status of previous actions? And we do. So when you look at an Ansible playbook, there's a very fine ordered list of operations, and it'll walk down that list and do one step, and then it'll wait for all those nodes to complete before moving on to the next step. So if any host were to fail, it's going to take that previous host out of rotation, so it's not going to try to talk to it anymore, which I thought was important. I was working with one particular other program in the past, and it would not fail fast, and it would do like half the configuration and not finish. And then be like, which half did it do? And it was like, the middle half. So Yeah, the idea that it fails and it takes the host out of rotation should be very useful, and then it's not going to continue based on other things. And if that entire batch were to fail, so if you were doing the 100 web servers and you carved out the 10, if that whole 10 were to fail, it's going to actually stop the run and not continue on. So definitely recommend the serial keyword if you're using that. Yes? The question was, do we have a rollback in the event of failure? So there's many people in the automation space that believe that rollbacks are a lie, right? So I tend to believe that. And I think the main issue there is, do you have data, right? So if you're talking about database migrations, did you write the reverse database migrations? Are they actually going to protect your customer data? And did it really understand what the failure was enough to actually go back? So so fail forward is typically the way that I would suggest that you fix problems. Make sure that you test in stage first, make sure you test in production. And if you're doing a rolling update, hopefully that you set the serial keyword to say, this is my batch size of my update, and when that fails, you have a block. But yeah, rollbacks are like one of the hardest things that anybody could figure out how to do. Yes?
Kind of an aside on that topic, I mean, really the only true answer to that is use something like ZFS or Butter as part of your project. First thing you do is take a snapshot, and on failure, roll back your snapshot and restart the machine. Yeah,
that could definitely work in some instances. Good deal.
Not using ZFS or Butter.
Yeah, absolutely. All right, any other questions? All right, well, thank you very much, everybody. I appreciate it. I've got lots of free Ansible Work stickers if you guys want to stop by and grab one, and thanks.
Thank you.
All right.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source. The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how Cloud Stack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of Cloud Stack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. These hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
Cloud Stack Management Server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using Cloud Stack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
Cloud Stack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think Cloud Stack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the Cloud Stack.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication. From Wicked.